This is the Building Automation Monthly Podcast with Phil Zito, episode 159. Hey folks, Phil Zito here, and welcome to episode 159 of the Building Automation Monthly Podcast. And in this episode, we are going to be wrapping up part 4 of our 4-part series on the 4 parts of a building automation system. So over the past 3 weeks, we have went through parts 1 through 3. We've talked about inputs and outputs. We've talked about field controllers, and we've talked about supervisory devices. In this episode, we're going to be talking about servers, which is actually quite timely because this week I'm in class for an N4 certification, and I'm actually taking it online. And one of the things we're utilizing as part of this course is utilizing virtualized machines and servers in order to do the exercises that are included in the course. Now, over the past few weeks, as I mentioned, we've been going through these 4 layers of a building automation system. And now in this episode, we're going to be moving into one of the most misunderstood topics in BAS, and that is the topic of servers. Now, why do I say this is one of the most misunderstood topics? Quite simply because I find people using servers like their clients. I find people not understanding why they can't have port 80 open on 3 different web servers, and why ports need to be open, and what services are, and what clients are. All of these topics that, if I'm honest with you, about 10 years ago didn't really matter. We were still dealing with thick clients, and occasionally we may have a kind of hybrid thick-thin client that was running some sort of Java application. But nowadays we are using purely web-based clients and web servers, and we're looking at architectures from a BAS perspective that involve multiple servers, involve virtualization, involve cloud, all sorts of technology sets. And because of this, we need to be cognizant of what servers are and how they work. Now, before we dive deep into servers, I want to tell you that this week's class is sponsored by our IT for Building Automation System Professionals online course. Now, let's face it, IT is something that you just can't avoid if you want to have any career in BAS. Whether you're an operator, an engineer, a salesperson, a technician, IT is something you need to know. But you really only have 2 options. You can learn on the job and just kind of fake it till you make it, or you can take a bunch of IT certification classes or go on like lynda.com or Pluralsight and take all these IT courses that are by IT folks who have no freaking idea about anything to do with our industry and are going to teach you a bunch of stuff you don't need to know, and they're typically only going to be teaching you about one part of IT. Now, our IT for BAS Professionals course teaches you what you need to know about all aspects of IT from a building automation system perspective. We're going to teach you networking, servers, database, remote access, cybersecurity, APIs, and much, much more with a bunch of hands-on exercises. Here's what some of our students have said about the course. So Milton, who works for a systems integrator, says, I think the course was very helpful in that, for the most part, it stayed focused on IT concepts that pertained to BAS. It was good that it cut out a lot of the stuff that you really don't need to know. I also feel much more confident talking to IT people and discussing what we actually need from them and what they need from us. And Patrick, who works for a major building automation system manufacturer, said, I have learned more in this course than I have in my entire career for IT. Now, you can sign up for IT for Building Automation Professionals by going to buildingautomationmonthly.com/159 and scrolling down and clicking on the IT for BAS Pros logo. Alrighty, folks. So servers, why are they used? How do they come about? What do we do with servers? Well, servers quite simply are computing machines, so computers, that serve a resource. So you may have heard of a printing server. You may have heard of an FTP server. You may have heard of a web server, of a database server, of an application server. All of these servers serve resources to machines. So FTP, so file transfer protocol servers, what do you think they serve? They serve files. Web servers, they serve web resources, typically in the form of HTML pages, but not always. Database servers, well, they serve database capabilities. So you can see pretty quickly that servers serve resources. What they don't do is they don't act as your user interface. They aren't meant for you to log into the BAS server, go and use it to browse the internet or use it to browse your BAS. They aren't meant to do that. The reason we use servers are to consolidate information and then serve out that information in the form of resources. Now, how this all came about was back in the day, about 10 years ago, we were still largely using thick clients. I cut my teeth on InVision for Backtalk and InVision for IBEX, if I remember correctly. I was an Allerton guy starting out. And then I moved to Johnson Controls and worked largely on their Metasys system. Then I moved into their system integration team and I worked on pretty much freaking everything. And it was at right about 2010, probably like 2012, 2013, that we start to see a migration away from thick clients to thin clients. So thick clients were these Java applications. They were these applications that would run on a dedicated machine initially, and this dedicated machine would be directly connected to the supervisory devices trunks. So remember, supervisory devices have field level networks, and then they have their network level networks. So their connections are typically at a IP level or an ArcNet level or an Ethernet level. Well, these thick clients would exist at that upper layer of networked technology and would gather all the data from multiple different supervisory devices and allow those supervisory devices to compute or to communicate, not compute with one another. I'm like, what? No, it's really late at night when I'm recording this, so you'll have to give me some grace. But thick clients, they would go and gather all this data from the supervisory devices and present it, but they were stuck. They were these thick clients that initially were on these machines in closets and in behind the facility director's desk, and they weren't going anywhere. And you had to actually log into that. Then, this thick client software became a little bit more mobile, and you could actually install it on your machine as an executable. And you would run this thick client software, and you would still connect to the supervisory devices network, and you would go and gather data. Well, then the thick client kind of took a hybrid approach. It was kind of a thick/thin client in that you had Java applications. So Tritium, Siemens, Johnson, they pretty much all did this, where you ran some form of Java or some form of mid-lightweight application, and it acted as an interface between a server that then was going and gathering the data from supervisory devices. So you got to picture this, right? We went from a dedicated machine that connected to the supervisory devices, that was a thick client, to this kind of mid-tier, kind of thick, kind of thin client where you're running this application on your laptop, which then is connecting to a application server that is then connecting to the supervisory devices. Then right around 2014, 2015, we started to see the adoption of pure web servers and HTML5 interfaces. And what this did was we still had an application server. And what I want you to hear here, we're going to talk about all sorts of different types of servers. We're going to talk about application servers, web servers, database servers. Just because, and I got to clear my throat for a second, so 1 second. Excuse me, sorry. So as I was saying, When you hear about these different types of servers, web servers, application servers, database servers, they may be on the same machine. So these are server roles, server capabilities. But just because a server has a capability does not mean it necessarily is separate machines. All right. So I just want to clarify that. So these web servers come about, and now people are able to use their web browsers. And these are truly thin client applications, because what's going on is that the client is actually the web browser, and it is going to a web server that is typically running on the same machine that the BAS application is running on. And what's going on here, right? I'm going to give you kind of a picture behind the scenes. You've got this application software that's been coded and it's been compiled and it's running, and it's typically running as a service. And this may be the Niagara Daemon. This may be, in the case of Metasys service running. And what's going on is it's running this application service that's both connecting to the database, but is also feeding information to the web server. And then the web server is doing some form of code calls. I'm not going to get into JavaScript and Ajax and stuff like that, but it's doing a form of code calls against the application, against the BAS application. This will be important when we start talking about APIs. But this web server is doing a call against these BAS applications, and these BAS applications are serving up resources to the web server. See that? That's serving of resources. Then the web server is then taking that data and putting it into a format, typically HTML, that is being transferred via HTTP and HTTPS to your web client, your web browser, which then knows to take these HTML files and encode them, or actually present them in such a way. It wouldn't be encoding, it would be presentation. Presenting those in such a way that the formatting represents a graphical page or textual page that you can then interact with. So that's kind of the evolution of BAS and kind of how servers came about. Now, as I mentioned, there's three types of servers. So we have our application server, we have our web server, and we have our database server. I'm going to kind of go through what each one of these does and how they work. But remember, servers and the building automation system. So what's going on here with servers is, while supervisory devices have the capability to do graphics, they have the capability to do trending, scheduling, alarming. Remember, they are much more resource constrained than a server. You see, servers can be infinitely scaled. I mean, literally time and money are the only resources that limit your scalability of BAS. Do you have the time and do you have the money to implement cloud solutions that are elastic? If the answer is yes to both of those, you can build a building automation server that will scale infinitely and will be able to be redundant, meaning that if it fails, it'll instantly fail over to another image, and be load balanced so that everyone in the world is interfacing with this server is going to be roughly getting the same user experience as far as speed and responsiveness. So your typical building automation system server is going to be comprised of three pieces. Piece number one is going to be the application server. This is going to be the building automation application. This is what is going to run the core code of the building automation software. So what's going to happen typically is this application software is going to allow for your BACnet IP interfaces, your Fox protocol interfaces, your LAN EI852 interfaces, your Modbus TCP interface, whatever interfaces. These are typically going to either use some sort of open protocol or some sort of vendor specific supervisory / server bus, messaging bus, and is going to communicate between the supervisory devices and the server and the database, and the server and the web applications. So this application is your centralized point. Now, from here on this application, you may have set up trends, you may have set up alarms, you may have set up things that require storing. In this case, what's going to happen is all of this information is going to be stored in a database. So you're going to have a database server that's running. And now you're going to want to be able to present the user interface to folks, and you want to be able to do it via responsive, mobile, HTML, all those kind of wonderful buzzwords. You want all those great capabilities. And in order to do that, you're going to run a modern web server. Now, this web server is going to serve up typically HTML pages. So that's hypertext markup language. That is a way of taking regular text and adding quote, unquote, markup to it so that that text can look different when you're actually viewing it through your browser. If you ever want to see that, you can press F12 if you're using Google Chrome, go into debug mode. You can actually kind of see the elements associated with a web page and how those elements and then things like CSS and JavaScript come together to form the actual full web page you're seeing. Now, something else that a lot of folks don't realize that most web servers do is most web servers also, and sometimes this is through an application, but most of the time this is through the web server, provide APIs. And those are application programming interfaces. So if we think about, and here's a good way to describe APIs, because a lot of folks are like, what is an API? What does it do? Okay, we think that we've got this BAS application, right? And inside this BAS application, it has functionality. And we want to interface with that functionality. So we want to interface with the programming of an application, hence an API. Well, an API acts as an endpoint for us to interface with programmatic functionality that exists within an application. So if you have the ability to read or write to a point, that is a programmatic functionality. In the terms of the BACnet protocol, that would be the read and write property services. Well, in order to execute those services and execute those programmatic functions, we need a way to interface with those programmatic functions inside the application. Hence, we have APIs. Now, most APIs we will deal with will be RESTful HTTP APIs, meaning we use the same protocol, HTTP, Hypertext Transport Protocol, that we utilize to transfer HTML files. And we're going to use HTTP and we're going to use RESTful commands. So we are going to be using commands like get and commands like post. Get is essentially read property. Post is essentially write property. Occasionally we'll use things like put and delete. But what's going on is we have these resources and we have these programmatic capabilities inside our applications, and we are going to call on these resources and capabilities by utilizing APIs. All right. Much more on APIs on other podcast episodes we've done. So if you want to learn about APIs, I encourage you to go back and listen to those. Now, supervisory device and server relationships. We've talked about this a little bit, but we have to realize that servers primarily exist to centralize the user interface and to gather data from multiple different supervisory devices, potentially geographically dispersed supervisory devices, pull all of those data points together, and then provide a unified view for the end user. That's the primary purpose of a server, is to gather up all that data and then serve it to a user, typically nowadays via a web server and an HTML5 interface. Now, whenever we're dealing with servers, we have to look at three critical topics. And that is the topic of virtualization, the topic of cloud, and the topic of security. I want to be clear that virtualization and cloud are not the same thing. You can do what's called an on-prem or on-premise or on-site virtualized machine. And basically, that is a server where you partition out the resources. I like to call virtualization basically timeshares for computers. So what you're doing is you're partitioning a portion of the memory, of the CPU, of the storage. You're partitioning that off for a virtualized operating system. And within this virtualized construct, within this quote unquote container, and no, we're not going to get into containerization and stuff like that, but within this virtualized container, you are essentially running a separate machine. Now, the beauty about this is, done right, you can have elasticity that stretches across multiple machines. So you can actually have a virtualization software manager that can utilize the resources from multiple different machines and can allow you to actually go and have unlimited CPU, unlimited memory, unlimited storage. Now, this is more so in cloud, which we'll talk about in a second, but can be done on-prem as well. It's just more expensive typically from a capital investment perspective. Now, virtualization is really cool for several reasons. One, uptime. It really enables you to have uptime because you can switch instantly over to another image of your server if that image that's running were to fail. The other thing is, as I mentioned, elasticity, the capability to expand your resource limitations. If you, for whatever reason, start to hit resource limitations, you can dynamically expand the amount of memory, of storage, and compute. The final thing with virtualization, and it just freaking slipped my head. Oh my goodness, it was right there. So I talked about resources. I talked about failover with virtualization. And there was a third thing, and it literally just slipped out of my brain. It's 9:30 at night, and I've been up since 3:50. So you'll have to forgive me. I'll come back to it. I'm pretty sure it'll pop right back into my head in a little bit. But next up is cloud. Now, cloud is not to be confused with virtualization. Typically, though, you are going to be using a virtual machine in the cloud. However, you can access a dedicated machine in the cloud. And that is not a virtualized machine. It's actually a dedicated machine. It's just hosted in the cloud. Most of the time, though, in the cloud, you're going to be using virtualization and you're going to be using load balancing. So what's going to happen is you'll typically utilize like a virtual private network that will extend the building automation network to the cloud. And that acts as a protected tunnel between your BAS server on site or your BAS system on site and the actual cloud server. Now, I want to tell you that when it comes to cloud, the cloud providers have two goals: security and uptime. They care more about security and uptime than your on-staff IT group does, unless you're like the Pentagon or something. So I'm telling you, a lot of folks who worry about cloud, they are more secure than most on-site IT groups. Folks don't like to hear that, but the IT group does not have the same level of focus typically that a cloud provider does, because if they have a breach or a downtime to their capabilities, that has ramifications for their entire business model, and they are for a for-profit entity. Okay, so as I said, these VPNs, they go and they map up to the cloud, and then you'll run either a dedicated machine or a virtual machine. And then from an interface perspective, you will typically go and have some form of load balancer, which will look at where you're at, and then will go and balance loads. Like if an interface in the US West is getting overwhelmed, they may go and balance some of that load to US East. Now, finally, the last thing I want to talk about is security. This is a topic in itself, so I'm going to give it kind of a brief overview. I'm not going to go extremely deep into this. But security is, as we start to get to servers and virtualization and cloud, it's incredibly important. We always got to remember the first rule of security. You're only as weak or only as strong as your weakest link. A lot of folks will say, hey, this has got to be super secure, but then they neglect the actual physical security. They say, oh, we've got to have this super secure BAS server software, but we're going to put the BAS server in the break room. Or we've got to have this super secure software, but everyone's going to use the same username and password. So when it comes to security, you have physical security controls, you have administrative controls, and you have technical controls. So physical controls are going to be, hey, this is in a locked room. It's got air conditioning. It's got backup generator. It's physically secure and it's on. Logical controls are going to be, hey, we've got firewalls, we've got intrusion detection, intrusion prevention. Administrative controls are going to be, hey, we're making folks reset passwords, we're invoking auditing to make sure that we know who's logged in when, we're actually using proper categories as far as restricting access to resources. So as I mentioned, security is a much deeper topic. And if this is something that is interesting to you all, just leave a comment at buildingautomationmonthly.com/159 and say, hey, Phil, I want to learn more about security. It's something that I know quite a bit about. And so I would definitely love to do an episode on that, but only if more than like 2 people are interested. If there's a lot of folks interested, because here's the thing, if you look at what goes on LinkedIn, or you look at Facebook, or you just look at marketing from companies, basically everyone seems to pick a message and then they all message the same thing. Like right now, everyone's messaging around AI. And I railed on this in the last episode. I talked about how, yeah, everyone talks about AI, but very few people are actually implementing AI. And they're all using the same AI framework from Watson because they don't have any AI staff to develop their own stuff. So, I see a lot of folks who talk about different things with security. Security is important, but you also have to realize folks' motivations when they talk about certain things. You have to look at the role they're in. You have to think, what company do they work for, and what could they potentially be trying to sell me by going and talking to me about this topic? I'm straightforward with y'all. We sell training. I provide free podcast episodes every week so that you'll say, hey, man, this guy's free stuff is really good. I should check out his online courses. That's what we do. I've not been at all unclear about that. So when I teach you all something, I don't have a motivation for you all to adopt a specific idea. I'm just here to educate. So I want to tell you all, whenever you hear about cloud, IT, APIs, virtualization, any of these topics, just here's some Phil wisdom that I've seen managing partner ecosystems, managing integration programs, working in this industry with all sorts of different, from Fortune, 50 companies to small mom and pop shops. Understand people's motivations whenever they talk to you about something. I know we kind of just completely went off the tracks there for a second, but I just felt like I needed to tell you all that. I don't want you all to get wamboozled by someone who's telling you something that definitely benefits them, but does not benefit you. All right. So with that being said, that's it for this episode. Man, it was a lot of fun doing this 4-part series. I'm not even sure what next week's episode's going to be. I got to figure that out. But until then, I'm going to let you all go. Go to buildingautomationmonthly.com/159. I really encourage you all to check out that IT course. I mean, there's nothing else like it in the market, and you will leave that course knowing exactly what you need to know about IT. So I definitely encourage you to check that out. With that being said, thanks so much for being here. Like always, I can't wait to talk to you all again next week. And until next time, keep learning, and I will talk to you all next week. Take care.